Hi and welcome. This is getting started with the IAR embedded workbench for RISC-V. For this demonstration, we are going to use the IAR embedded workbench for RISC-V, which comes with CSTAT, the static analysis tool. Also, we use the IAR iJet debug probe. When we start the embedded workbench, you will have access to the information center where you have the product explorer with tutorials, the user guides, and the example projects. If you click on the example projects, you have a list of different manufacturers such as Andes, Cloudbear, GigaDevice, Microchip, Sci5, and Syntacore. Once you select your example project, you open it. Here we have already one opened. I will click on the mains.c file and it will open on the code editor. So we can see the main function here. This loop will convert the temperature in regular intervals, and for every conversion, it will print. Now if I right click on the project name and choose options, I can go to the general options and select my target device from different vendors, as you can see. The next category is static analysis. Here you can select the CSTAT checks. It comes with the standard checks pre-selected, but you can choose others such as CertC, Security, or MISRA C 2004-2012. And also you can select or deselect groups of checks or even individual checks. Once you got your check selection, you can export the settings and then import on the other development machines. There are some other options such as parallel analysis, timeout, enable false positive analysis, and also you can limit the message per check. The next interesting category is the C++ compiler, where you can have access to the optimizations tab. Here you can select the level of optimization from none to high and optimize for speed, for size, and also select and deselect individual transformations. For a better debugging experience, we will leave the optimization level on low. The next interesting category is the debugger, where you can select between the simulator and the iJet. And embedded workbench will insert an automatic breakpoint on the main function for you. Now let's click on the Make button so our project is built. And as you can see here, we have no warnings, no errors, which is great. And then if you unfold the output, you will have access to the map file. And on the map file, you will see the exact layout of your application on the flash, on the RAM, the initialization table, the functions, the modules, and then the resource usage in both terms of ROM and RAM. Now let's right-click the project once again and let the CSTAT analyze the entire project. As you can see, a CSTAT message window will open and CSTAT will populate it as it analyzes in parallel the files. And as you can see, the number of messages increases, and once it's done, you get the total amount of messages here. Every message brings the check name, the severity, the file name, and the line that it occurred. You can filter here. Let's say you want to see only the high severity messages, and if you select it and press F1, a help file will pop up and it will show you if it's enabled by default. There is also a severity certainty matrix, a full description, the coding standards it violates, and it always will bring you some code examples of a bad example and a good example. So now let's go back to the cstat messages. I will show all the messages again. Let's find out the I2C file which had the high severity level. It was this one. And we have a division by 0 here and another medium one. Let's go to the highest severity first. And here we have this clock speed variable on the denominator. It comes from a parameter for this clock configuration function, and this function could be invoked with clock speed equals to 0, which would crash the application. So let's insert this condition here just as a checkpoint to make sure that this function is never invoked with clock speed equals 0. So now to save time, let's only select the I2C driver file and we will run the cstat to analyze only this file. As you can see, for this file there is one message left, and then you should repeat the process for your entire application, making it more robust. Cstat also comes with automatic report generation. In order to use it, you just select to generate a full HTML report and save it on the project folder. Your browser will be open, and here we will be able to see the top 10 messages, the top 10 files, messages by severity, and the details of the selected checks that you have previously selected on the cstat configuration, and the messages per file. On every file, you can access and get the message details for that file, as you can see here. Now let's review the project, and then let's start a debugging session by clicking Download and Debug. The CSpy debugger will start, and it will execute the C startup sequence until it reaches main. Then on the view menu, you can select multiple views such as the stack, the call stack, and you can even reposition according to your tastes. Let's say you want to save some screen space, you can, for example, hide the workspace. You can also view the registers. So let's reposition it a little bit here, resize. And in this view, you have access to different peripherals. Let's say you want to take a look at on the ADC, for example. Another great feature to mention is the ability that CSpy has to detect the core type and every extension available to that core. For example, here we can see the atomic, the compressed, the integer, the user mode, and the non-standard extension being automatically detected. So now let's start debugging with something simple but essential, such as stepping throughout the code. As you can see here on the right side, we have the step into button and the step over button. We can step into the function and we can step out of the function. And this stepping control can be performed on both C editor side and also on the disassembly side. So now let's set a breakpoint on line 46. Just click here. And I will also enable the terminal IO. So we now can see the output, which is the printf statements that we've seen before. And now as I execute the program, it will halt the execution on the printf line 46. I will close those views that we're not using right now and reposition the terminal IO. So now let's say I want to monitor the temperature variable. I right click on it and then choose add to watch. And I will reposition here And okay. On the watch window, I can add new variables from there, and I also can edit the contents of a certain variable if I want, and also choose the display format to hexadecimal, for example. So now let's hit the go button and let the application run until it reaches the breakpoint again. As you are converting temperature, perhaps you want to leave it running for a while. So let's go to breakpoints and click on edit this breakpoint. Then here we can insert a special condition to break it when the condition becomes true. Let's say we want to break every 5 conversions. Hmm? So we just write it like this. So now we have a conditional breakpoint. And this breakpoint will happen only when the condition becomes true. In this case, multiples of 5. Also notice that every time a variable is updated on the watch window, it's painted in red. But as we are dealing with temperature conversion, maybe your application requires some time to be executed. So what you can do is disable this breakpoint temporarily or enable it as you want. And let's disable it and keep the application running. And even more than that, Embedded Workbench provides you with the ability to leave the target running even if you disconnect from the debugging session. So in order to do that, you need to select this option. So now to test it, let's terminate the debugging session. And then on the project menu, I can attach to a running target. So it restarts the CSPI debugger. And as you can see on the terminal IO, the conversion counter is counting where it was. You can pause the execution and even re-enable your previous breakpoint here. And it will go until it reaches the 20th conversion. Thank you for your attention. And in case you have any questions, please feel free to reach out to us.